Chapter 1, Exercise 19. Hints. Use the technique of completing the square. Solution. We examine the difference of squares. 2 absolute value x minus b squared minus absolute value x minus a squared equals 4 absolute value x squared minus 8 b dot product x plus absolute value b squared minus absolute value x squared minus 2 a dot product x plus absolute value a squared equals 3 absolute value x squared minus 8 b dot product x plus 2 a dot product x plus 4 absolute value b squared minus absolute value a squared equals 3 absolute value x squared minus 2 4b minus a over 3 dot product x plus 4 absolute value b squared minus absolute value a squared over 3 equals 3 absolute value x minus 4b minus a over 3 squared plus 4 absolute value b squared minus absolute value a squared all over 3 minus absolute value 4b minus a over 3 squared, continuing, equals 3 absolute value x minus 4b minus a over 3 squared plus 12 absolute value b squared minus 3 absolute value a squared minus 16 absolute value b squared plus 8 b dot product a minus absolute value a squared all over 9 equals 3 absolute value x minus 4b minus a all over 3 squared minus 4 over 9 absolute value b minus a squared equals 3 absolute value x minus c squared minus r squared, where 3c equals 4b minus a, 3r equals 2 absolute value b minus a. It follows that absolute value x minus a equals 2 absolute value x minus b if and only if absolute value x minus c equals r. Comments. We get r greater than 0 if and only if a does not equal c. Otherwise, the problem becomes trivial. The result of this exercise means that the set of points with a fixed ratio of distances to given points a and b is a sphere. In the case k equals 2, the circle that we obtain in the solution belongs to the family of so-called Apollonian circles. An example of an Apollonian circle. Given 2 points a and b, the circle is a locus of points x with a fixed positive ratio of distances absolute value x minus a all over absolute value x minus b. Points L and R are intercepts of internal and external bisectors of an angle AXB, with the line that passes through A and B. Thanks for watching.